My name is Tom DeFanti, and I'm going to start this thing off. We're going to talk about the living laboratory of Iron Horse Vineyards. Yesterday, John and I talked about the tech behind it from the kind of hardware side, and now we're going to look at the software and the workflow and the motivations and some videos and things like that. So I'm going to get started, and so Joy, it's your turn.
Well, good afternoon. I am going to begin by saying thank you. I have a lot of people to thank, and number one is Louis Fox. I am so honored to be your partner in crime. And Louis, you have the courage and the creativity that has brought this together, and it is just such a thrill to be a part of it. And thank you for welcoming me into the CENIC community. I'm really very honored to be with you all. I feel that my life has opened up. I also want to thank Chris Congo from AT&T and his team for restoring my faith in American ingenuity. They brought such magnificent connectivity to Iron Horse in an environment where basically people feel it's impossible. Fiber to the farm is impossible. That's all you hear all the time. It's impossible. Well, we are here to show that it is very doable, and AT&T did it in record time. So they really deserve kudos and a acknowledgement as a partner in this whole process. To me, what's really exciting about this is Louis's vision of bringing agriculture as a new pillar of CENIC. And part of being part of the CENIC community means that a lot of this is focused on education. And it is so validating to be with these co-presenters here, the students, the faculty. It's the research, it's the learning, it's the teaching, it's the doing, and it's the sharing. It's the sharing, and I think that's where this community is so special, before that belief in open source. Farmers generally are very proprietary about our data. And so if I could brag about myself, the only thing I would say is that we are very happy to be sharing our data and giving the new generation the opportunity to pull the data together, work with the data, know how to use it, and to share it. It's really fantastic. I also want to thank John Graham, who, besides bringing his unbelievable brain power, literally got into the dirt for this project, quite literally, and climbed onto the top of our roof and climbed through the crawl spaces and all kinds of heroics. And I want to acknowledge our impresario, Tom DeFanti, who brings us all together and keeps pushing us to answer questions, or more importantly, pose the questions. Figure out what are the questions. So that's really exciting. So, and also this presentation was put together by Tom, and it is exquisite. So I just credit where credit is due.
And I'm pushing the buttons. Ready?
Yes, he is. So I'm afraid to do it, so go ahead. So this is a very exciting year for us. This is our 50th anniversary, and thank you. It's really very thrilling. The place was founded by my parents, Audrey and Barry Sterling, and it is a very, very magical place. And I think one of the privileges that we have is it helps getting people to work with you if it's in a beautiful place like Iron Horse. It's not a bad place to put your office. We are at heart, we're all about stewardship. 50 years means we're only halfway there. Sonoma County has a Century Club, and it is absolutely my goal for us to be one of the families that have been farming in Sonoma County. We want to hit at least 100. After that, I figure it's not so much my job. Someone else can take care of it. But the first 100 years is my job. And it's exciting that we think of innovation and stewardship as two sides of the same coin. So to us, they really go together. Next.
Okay.
My personal interest in being here stems from being a very active broadband activist, and for rural broadband in particular, and precision agriculture. And I had the privilege of serving on the FCC task force for precision agriculture for 8 years. And one of the major findings of that report, the final report, was the need for test beds in America. So on a very personal level, this is a fulfillment of 8 years of work and research and study. And it's a classic case of find a need and fill it. And we are really perfect for this job of hosting the test bed site because of our degree of difficulty. We're remote, we're very hilly, we make it as hard as we possibly can. And I think that that makes us the perfect test bed for other people to be able to learn from. We only use our own grapes. The vineyard is broken up into 28 different blocks. Each block is farmed individually, harvested individually, vinified individually, and then we sit down with all the different possibilities and make our blends from that. Being estate bottled has advantages for this project. On the one hand, we've been farming here for 50 vintages, so we have some idea of what's in store. And more importantly, I would say, because we only use our own grapes, being estate bottled means that it is the foundation of our belief system that this property is capable of yielding unique flavors. And that what we're trying to do through our farming, through our viticultural techniques, is bring those flavors forward into something that, even if you have access to our data, you cannot make this at home. And that is the key. So from a selfish standpoint, part of what is exciting about this for me is that giving us the tools to hone in and get better and better at our viticulture is going to lead us to be able to make better wine. And that is job one, distinctive, delicious wine. In fact, our entire marketing program is to make wine that is so delicious that you wake up at 2 o'clock in the morning with an undeniable thirst for Iron Horse, and absolutely nothing else will do, not even chocolate milk. I don't know what's wrong with me.
7 NRP, come to 7 NRP. We'll have
I am just mortified. When have I ever gone anywhere without wine? Particularly if you want to make friends, bring the wine. I don't know. Next time, if I'm ever invited back, I now have learned that, thank God it's a test bed, you know, and we learn as we go. So one of the great points of pride for us is John swears that we are the only vineyard with a science DMZ. And I just wear that as a badge of honor. I think that is absolutely fantastic. And having this magnificent broadband bandwidth allowed us to add the Firewatch cameras, which is another thing to be so personally proud of. It covers our entire viewscape. And that to me fits so perfectly into our sense of community, that we share that. I mean, who has that kind of capability? And so you have to share. You have to share that. So that's tremendously exciting.
Ready to take off? Here we go.
Zoom. That's the Scenic Air Force. And it's hard to tell the topography, but you can get a feeling for the beauty of the place, the magic of the place. And we're going to where one of the sensors is now, which is fun. And part of what we're doing, and you'll see more about this later in the program, is we've got sensors at the top of a knoll and sensors at the bottom of a knoll. And we're going to be able to evaluate quantitatively and therefore qualitatively the difference between those 2 points. This shows you how much wildness there still is at Iron Horse, and this is a creek restoration project that we finished just last October to help restore coho salmon returning. Believe it or not, Green Valley Creek is a favorite corridor for coho salmon. I mean, who would blame them? We all want to come here. It's so beautiful. And again, I love that we rep both. It's the stewardship and the innovation. Here's just a beauty shot of that salmon habitat. These are slides that I really wish you would take a moment and read, because these are the use cases. And so this is what's really exciting. So one, frost. We're 13 miles from the ocean as the drone flies, and we're prone to frost as late as June 1st. And so that's at a critical time for the vineyards, and you can lose half your crop in one frost incident. The way we protect for frost is through water from a reservoir. It's all recycled water, by the way. And it goes into 6-foot tall sprinklers, and then they just rotate very quickly. And two heroes, Manuel Briano and Jose Puga, if we have an alarm go off that the temperatures are dropping, they go down to the reservoir, they prime the engines, and once you start the water, it's got to keep going, because you don't want to freeze your own grapes if the temperature dips back down. But then their job is to drive around the property to see if any of those sprinklers are plugged. It's a pretty miserable job. And what we're excited about is the potential of a drone. Well, number one, a sensor telling us if there's anything plugged in the water line, and then a drone taking us directly to the sprinkler that's plugged. Now, they're still going to have to get out of the truck and get wet in the middle of the night. But it is far superior to driving around aimlessly. Canopy management is huge. That is one of the main drivers of quality in wine, and that is making sure that the vine has enough energy to maintain its canopy as well as bring the fruit to maturity. And too much canopy, you're going to get too much covering of the fruit area, and that makes it prone to mildew, particularly in a cool, foggy area like us. And with climate change, it seems as though it's very likely we're going to get cooler and foggier. So not only is it going to tell us where to go to pull off more leaves and give balance to the vine, to let more air circulate through, more sunlight come through, but also it's going to create for us a whole new data set of where the fog is going, because it's changing, and it may be that those areas that we're used to worrying about in that regard, it may be that other areas are also going to be susceptible. Heat exposure, heat smoke taint. These are all new emerging threats. And this is another part of this pilot project and the test bed concept that we're making it up. I mean, every day John and Tom say, well, what do you want to know? And we don't even know what we don't know. And that's kind of the point, and that's what makes this such an exciting adventure. And then there is making it so it is shareable, so that it can be analyzed, so it can be used. And the concept of having a digital clone of Iron Horse is just so amazing to me, because what that means is that others will be able to, you know, the joke is that if you've seen one farm, you've seen one farm. It's all of this infrastructure is very site specific. But once we have a digital clone, anybody can play with it and come up with different configurations of what needs to be done. And we're going to make all the mistakes for them to begin with. The most important goal of this thing, in my estimation, is just for us to be ultra cool.
Well, you're on your way. All right, so I just want to go over the testbed timeline. This really is, less than 2 years old, and 15 months ago, we met at Joy's house and decided to do this. And AT&T said, yeah, we're going to set up a circuit. And 3 months later, it was in. And we couldn't believe it. We were not prepared for them being that fast. And then we put in, John installed switches and routers. And yesterday, we went over the tech. But also, we started getting Sonoma State University people in. And these folks all came and just, they never left. So they've been really plugged in. And as you'll see, they've been building databases and teaching. And so we have, and yesterday we talked about this, we have 112 sites, sensors in 26 modules in 4 different places in the vineyard, top of and bottom of the hills. And some are mounted near the wine cellar, which of course is above ground. And all of this data is now available on your phone. There's a little URL I put up yesterday, and you can look at this stuff anytime you want on your phone with great detail and all the graphs and charts. And so, you can, you'll see the talk from yesterday when it's up on YouTube, or, you can send me, and we'll abuse our bandwidth by sending you a gigabyte file. So now it's off to Joe, and Joe, why don't you grab that mic and come up here? Yeah, you mind just taking out the thing.
All right, I'm Joe Ording, and this is Jake Gonsalves. We're 2 of the Sonoma State students that they couldn't get rid of. And so we're lucky to be interns at the CENIC Iron Horse project. Our role focuses on two main things. First is capturing high quality footage using drones and the Insta360 camera. Second, using CENIC AIR to build a system to store and organize that data so that it can be hosted on the national data platform and used effectively for research projects like those at Sonoma State that we'll talk about later in the presentation. We're working across the full pipeline from how the data is captured in the field to how it's stored, processed, and ultimately shared for research use.
And I'm going to take over with the data capture side. One of the biggest challenges with drone-based data collection is consistency. It's not just about flying the drone and recording video. It's about capturing footage that's repeatable, well-structured, and usable for later analysis. If different flights are captured in slightly different ways, different angles, spacings, or coverage, it becomes much harder to compare results or build reliable models from the data. To address that, we're developing a set of standardized flight patterns and capture protocols. A big part of all that is the hardware itself. We're currently using the DJI Mavic 3 multispectral, which gives us both high-resolution RGB as well as multispectral data across several bands. Instead of manually flying in an ad hoc way, we're using UGCS automated UAV software to create predefined flight paths. These are waypoint-based missions where we can control altitude, overlap, speed, and coverage, so every flight follows a consistent plan. That removes a lot of variability and makes data much more reliable. Those flight paths include things like grid sweeps, perimeter orbits, and altitude stack passes. Together, these help ensure that we're covering the same spatial regions in a consistent way across different sessions. That's especially important as the data gets used over time for comparisons or modeling, where consistency directly impacts the quality of the results. And that's just a photogrammetry flight I recorded. In parallel, we're also using an Insta360 camera to capture full 360-degree video at ground level. This adds a lot of value because instead of committing to a single camera angle during capture, we can reframe the footage later in software. So we're not locked into one perspective. We can extract different views depending on what particular research task we need. And this is a video of Joe doing the 360 walk. The flexibility of it is really useful for research applications where different teams might care about different perspectives or features in the environment, as I mentioned. It also helps capture more context overall, which is often missing in traditional single angle footage. As the canopy grows, the 360 footage gives us coverage underneath to see the grapes and branches from below that would be difficult or impossible to capture with drones alone. But capturing quality data isn't where our work ends. An equal challenge and a crucial one for long-term impact is making sure that all of this data is actually usable. It's one thing to collect video and imagery, and it's another to turn it into something that can actually be analyzed, compared, and reused. That's where the storage, processing, and cataloging pipeline comes in.
So we're building this pipeline on CENIC AIR, which gives us a scalable, distributed environment to both store and process the data. We're designing it with a few key goals in mind: scalability, traceability, and accessibility. First is scalability. The drone and 360 video data gets large very quickly. One day of capturing can easily generate tens of gigabytes of storage. By using CENIC AIR, we're able to store large volumes of data in a structured way and also run processing workflows directly where the data lives. We're organizing the data hierarchically, primarily by geographic block, which is determined by the vineyard, then by capture date, device, and session, so new data can be added continuously without disturbing the system. Second is traceability. For research use, raw footage isn't enough. You also need context. So for every capture session, we're associating metadata, things like location, time, flight parameters, camera settings, and relevant notes about conditions. This comes in many forms. Sometimes it's embedded with an image. Sometimes it's in a sidecar file or in a trailer block at the end of a video. We're also automating this as part of the pipeline. When footage is uploaded into CENIC AIR, its metadata is automatically extracted and cataloged with a consistent schema. That way, researchers won't have to guess what they're looking at. They can query or filter data based on specific parameters. We can support reproducible workflows downstream, which is also important considering the different varieties of data: drones, Insta360, images, video, plus the sensor data that John talked about in his presentation yesterday. Knowing where that all is allows you to combine it in different ways. Third is accessibility. The goal isn't just to store and process the data, it's to make it discoverable and usable by a broader community. That's where the National Data Platform comes in. We're using NDP as the cataloging and access layer on top of our CENIC AIR storage. After data is ingested and organized, we register it in NDP with its associated metadata, which allows users to search for data sets based on specific criteria without needing direct access to the underlying storage. And importantly, it enables us to make the data openly available to other researchers. Instead of keeping the data siloed within our project, it becomes a shared resource that others can find, access, and build on. When every data set follows a predictable structure, it becomes much easier to build tools on top of it. This includes reconstructions like 3D Gaussian splatting or neural radiance fields, as well as visualization, simulation, and machine learning workflows. These are demanding tasks that are ideal for CENIC AIR. The Gaussian splat on the right took almost 21 hours to create on M4 Mac Studio, which is not really a slouch. The one on the left took less than an hour to generate on CENIC AIR and looks quite a bit better. So instead of just capturing and storing raw footage, we're enabling and exploring a whole range of downstream research applications.
And then putting it all together, the workflow looks like this. We capture the footage using standardized drone flights in the 360 camera. We upload and process the data with CENIC AIR with consistent metadata, and then we publish and catalog it through NDP so it can be discovered and reused. The end result isn't just a collection of videos, but a growing, open, and reusable data asset. That's what enables downstream research, whether it's computer vision, simulation, or environmental analysis, because terms can spend less time combining through data and more time actually using it. Overall, our contribution is about bridging the gap between raw data collection and open research access, making sure that we're capturing in the field, that what we're capturing in the field can drive meaningful work going forward. Thank you.
Go ahead.
Hey everyone, I'm Roya, Salek, and Dr. Sara Kassis. We're here from Sonoma State University, and we continue the presentation. So the story of collaboration between SSU and Iron Horse Vineyard started last December when we met the team in their beautiful vineyard, and we were so excited about this project, which is more than a project. It's combining technology and agriculture, somewhere as happy as a vineyard. For Iron Horse Vineyard side, they were excited to, have our assistant in the team for a data-driven vineyard management, for vineyard monitoring, having automated, access and monitoring to their vineyard. But on our side at SSU, we were super excited to involve our students, and we found this as a great opportunity for our students to have hands-on our real-world data, real-world experiment, and work with these phenomenal technology and data that they already have and make them ready and competitive for future and in job market. We already, our students are already exposed to these industry standard tools, and we use them from data processing all the way to visualization. And I want to call out our data team and VR team. We have two teams that data team is more supervised by me, and our VR team are supervised by Sara here. Three of our students, Kate, Samuel, and Andres, are here. Shout out to them for their great work. Enrique and Will could not join us, but they're doing a great job. So here, I want to talk about the vision that we have and our pipeline, the proposal we have. So as you see, we have drone data and 360 data collected from the vineyard, and the question was, how can we analyze and visualize these data for a better data-driven management system? And the two analysis approaches that we came up at this point, the first one is the NDVI filtering, and the second one is using an AI model to train the model to find any issue or any affected disease or issue that is coming with vines. All of these results, these findings, are visualized in our VR setting that Sara is going to talk about it more. But as the first approach, using the NDVI concept on the drone data, we had to educate ourselves, like, what is NDVI? I'm sure most of you find it really easy to understand, but for us as CES folks, we had to understand what is the concept and how to compute the vegetation index to get a heat map from the vineyard health. So we pre-processed data. There was an alignment issue, and we compute NDVI to have a threshold, have a classification of balance and suboptimal data that we get from the vineyard. This helps us to generate the heat map, and it's a really easy, I can say the fastest way to filter and quickly detect what are the regions that may be suboptimal and they need more attention in a larger scale. But that is great, we can filter data, but if we want to look at like more detailed image and high resolution data that is gathered by 360 camera, we can use that imagery and teach our deep learning AI model to analyze individual vines. So our target is to find probably like leaf abnormality or disease patterns or pest damage, any case that can be damaging vine, we're able to find by our AI model. So the first approach here for AI model is anomaly detection, which the bigger idea here is to train model only based on the balanced vine, and so it can detect anything that is different than our balanced vine. The techniques that already has been applied and we're following the same steps is like one of them is autoencoders. As you see, there's a research that already applied this method, and we're trying to do the same thing. As a second approach, we're trying to use transfer learning, which is suitable with the low number of labeled data that we have from this data set. And the idea is to use a pre-trained model and use our small data set that has been labeled and retrain it and tune the model based on the feedback we get. So I hand the mic to my colleague, Sara.
Thank you, Roya. And so we take the data that is coming from the AI algorithm, of course, the processed, and of course, showing the NDVI, to put this in the VR environment so someone can actually visualize it, whether viewing it on a computer or by using a VR headset. We also take the data coming from the 360 footage, and of course that has already been processed by the AI algorithm to detect these suboptimal imagery, to also visualize this on the VR app that we are creating. And so both the NDVI content and the processed 360 footage will be visualized on this app here. One of the features we plan to implement is some sort of feedback loop. And the feedback loop is because the AI algorithm is going to be trained on a very minimal set of imagery to teach it what is considered to be suboptimal. So Joy and her team of winemaking experts can actually view the content coming from the AI algorithm, and they can actually confirm or deny whether or not this imagery is actually truly suboptimal. This information goes back into the AI algorithm in order to further teach it what is considered to be suboptimal. So this will continue the AI algorithm training. So once we, of course, put on the VR headset, let's say, or view this on a computer, we are able to see the NDVI material here. So enclosed here in the red circle, you will see a region that has a little bit of red spotting, and this is what is considered to be suboptimal on this plot of land here. Now, a user can go ahead and select this plot of land, and they can take a look at this information in a closer way. What you see here is actually some of that drone data created as a 3D asset, and overlaid on top of that are pins that a user can actually select. These pins are actually geo-referenced, and of course this information, the latitude, longitude data, is actually taken from the drone footage or the 360 footage, and we are able to visualize that on the app. So a person can actually select on one of these pins so that they can actually go inside of the 360 immersive environment. And so they're able to view what someone would see if they're actually walking through the vineyard. Now, this footage that you see here is taken some weeks ago, maybe over a month ago. But of course, as somebody is using the VR headset, they are able to, or viewing the app, I should say, they are able to view this in 360 mode, so they can actually take a look at the vineyard location. The way that this model here you're seeing right now has been created is that a user can actually select a button at the top left-hand side, so they actually can go from one pin to the next pin within what we call photospheres. On the bottom right-hand side, we see some sensor data, and so this data, of course, correlates to that particular location for this image that we see here. So both teams, both the data team and the VR team, are working on combining the sensor data, so what Tom mentioned, of course, earlier in this talk, and as you can see an example of what some of that sensor data could look like, and integrating that into the work that we're doing. We are planning to formulate this pipeline of data into the VR app and working on the functionality of the transitions from each of these levels. And of course, it's expanding on the interactive analysis for that feedback loop to furthermore train that AI model. In a separate but related project, I do want to introduce Roya's project here that using a ground-based mobile robot in order to collect data, which is a project that she's been working on and has collected half the funds already and is looking for a sponsor to throw in an additional $8,000 to $10,000. If anyone is interested to be her sponsor, please come up and speak to her at your convenience. Thank you so much.
So those of you who know me, oh, by the way, NDVI is normalized difference vegetation index, and it measures vegetation health, density, and vigor by calculating the difference between near infrared and red light. Thought you'd want to know that. So I'm a camera guy. I've always got into computers because of being interested in cameras and visualization and everything else. So we put up cameras here, and here's our Iwo Jima shot. I showed you this yesterday of some roofers and Work for Joy and John up there on the roof about 45 feet above. And here's what it looks like. This is a drone shot here of flying around looking at it, and you can see the view. Now, this is what we get out of these HP Ren 4 cameras. We get this panoramic view. And so 4 fire cameras give us that. And every once in a while, besides just the beautiful daytime view, we see something like this. So on 11/11, we got an aurora, that far south, which is unusual. And then we put in yet another camera, this Axis Q63 camera, and it's a 4K 10 times zoom camera. And you can see the effect of having that camera way up there on the top and then looking down at the tasting room, basically. And then if you can look all the way, there's this little poinsettias there in a pot, and you can see it really zooms in. So for this kind of thing, we can look out into the steer it, look out, and pick up fire events and so on, and it's one of the 1,000 now Alert California feeds. So back to Joy.
Well, this is a summation. This is, tell them what you want to tell them, and then tell them again, and then tell them what you told them. So these are our goals. And my ulterior motive in attracting young people into viticulture is so I can retire, and and farming in general absolutely needs a new influx of talent. And my hope is that the technology is going to be the perfect lure. Though every time I mention it to these guys, they just shake their heads. They say no, but maybe it's early. It's early in the game. I do feel incredibly proud, particularly after hearing such a great talk about the difference between learning by seeing and learning by doing that this is exactly the kind of education that only a living vineyard can really provide. So it's really an honor. It's an honor to do that. The point of sustainability is obviously crucial. Every day we find more reasons why that is so much, has to be at the forefront of everything we do. And navigating climate change, we just simply don't know. And so this is an opportunity to have the tools to help us. The biggest thing for me is, scenic air is probably the best thing to happen to California agriculture since the tractor. So thank you. Data is the new tractor. And that is what this is all about. So thank you very much, everyone.
We have 3 minutes and 40 seconds for questions.
Are you worried with climate change that you might need to change varieties of grapes?
Well, that's, first of all, excellent question. And that's happening in many places, as well as growers changing where they grow certain, just going north, basically. There's that movement. I don't know, but I have a feeling that strangely we are in a very peculiar location, that we are not going to get hotter. We're going to get conceivably cooler and foggier. So, Larry, you'll love this. We might be more burgundy in the future. Oh my God, how dreadful. But can you imagine? So I think that we personally are not in danger of that. But I think that certainly in many areas, there's a lot of research being done on hybrids that might be better suited to different climate. And, it may be that it turns out that, Napa used to be famous for Cabernet and Sonoma more for Chardonnay. Well, that could change. That could change. And, but I don't think anybody in California is quite yet changing varietals.
Microphone over here. Can we get a microphone?
So
Oh, we got one over here.
just a real, maybe a little ahead of where you guys are or planning to be. To what extent are you thinking about integrating augmented reality to sort of bring the human intelligence together with what you've built and put it into a real-time kind of mode? I think that from a learning experience, that's one value add, but from a management perspective, I think it would be rather interesting. Any ideas around where you might take that?
No.
Yeah. So I do. I do. It's my field. So one of the interesting things about walking down the vines with these 360 cameras is you actually have an augmented reality experience, and because you can only go one direction, forward, backward. If you go sideways, you cut your head off. So it actually gives you a very realistic, linear, immersive experience. So that we will work with that. Whether you do it in stereo or not is another whole story. Let me talk to you about that tonight at the reception.
Let me add one thing to that. When I said no, one of the things that's virtually impossible is for one person to walk the whole vineyard. It's 200 miles. So now we do end up covering the whole vineyard. So that is certainly an instance where that'll be helpful.
So Roya's robot could do that. But I just don't want to forget, I want to thank Hunter Hathaway for giving me the lovely slide template for this presentation. Thank you, Hunter.
So I just, Jeffrey Weekly, UC Santa Cruz. I just have a quick question. I've observed this in other other domains where, especially observational things like astronomy and microscopy, where observing change over time and having time series data is really important. Could somebody on the panel, maybe Joy or someone else, maybe speculate a little bit about how the value of these data will accumulate over time, and maybe perhaps someday be have a very, very long tail.
Well, I'd like to just say one thing first, and that is that we replanted almost all of our vineyard in 2005. One of the little known, at least my brother and I were not aware that every generation gets to replant. We don't remember seeing that in the fine print. It was quite a shock. But in the process of replanting, we went through extensive soil analysis, weather analysis. We even redirected certain rows. We changed the spacing. We chose all different clones and rootstocks. And all of that information is historic, including the fog patterns. So that's exactly part of what's happening here is like we're now studying a different ring in the tree. Where is the fog pattern now? You know, what else is changing? And so developing a different set point of where we are today. This vintage right now is running 2 weeks ahead of 2 weeks. And one thing is very clear is the vineyards don't care. They really don't care what day it is. They're just going to move forward. And the only thing that you really can look at is the health of the vine. And so what's important here is not to really be worried about what's changing, but how to respond to the changes.
So we're over time, but let's get just one quick question.
My question is, I'm really excited about the direction this is going with precision agriculture and specifically in the wine industry. And I wonder, with wine being kind of dipping in demand and this really being pushed in that direction, do you foresee that would be a detriment to the entire agriculture industry, and how do you remedy that and really replicate this across into other agriculture spaces?
Well, first of all, wine consumption is definitely in decline. There's no doubt. We're facing a lot of headwinds, but it's not the first time. And wine has been around for, 8,000 years at least. They keep finding older amphora. So I think it's a cyclical situation. So that's number one. But I think that definitely viticulture falls into specialty crops. And so a lot of what we're learning in the vineyard will be applicable to other crops and other vineyards and other farms and other circumstances. And I think that particularly the process of setting this up is something that someone's got to do it the first time. Perhaps you all would like to add to that.
Well, we're over time, so let's do this later. I want to thank the AV crew here. This is the best AV crew I've worked with in years. You guys are really slick. So.